Hello guys, this is Thomas Khan, and today we're going to see the geothermal energy sources. Like previously, we've tried to cover different kinds of renewable energy sources, and for today, it's going to be the geothermal energy source. Mainly, I think the first one was biomass energy or bioenergy. The second one was hydropower. The third one was wind energy and then solar energy. But today it's going to be geothermal energy, mainly the energy that we get from heat of the earth. Okay, so I want you to stay with me and stay focused. So this topic is all about geothermal energy. So the first thing that we have to ask, what is geothermal energy? What do you know about this? What is geothermal energy? This is the first question that we have to ask ourselves. So it is simply the heat energy of the earth. It's like the energy that we get from the heat of the earth, generated by various natural processes. Like we'll come to the process, but it's kind of the first one can be the heat from when the planet formed, like which has not yet been lost, like it's deeper in the ground. So that is the first one. The second one is decay of radioactive elements, and the third one is friction. So as you can see, we don't have temperature distribution in the earth. As we go deeper and deeper, it becomes hotter and hotter. So the deeper you go, the hotter it is. So as you go here deeper, it's going to be hotter. Let's say if you take here a depth in kilometers, this one is 2000, and right here is around 400 degrees Celsius. If you take around this, which is 6000 kilometer, it's gonna be 5000 degrees, which is really hot. So we can use this energy source to generate electricity, or to what we call to like industrial purpose. It could be for any kind of thing that we need. But the question is, how does it really work? So we're going to see that point really right here in the next slide. So what is geothermal energy? This is the question, the first one. The word geothermal originates from Greek roots geo. Geo means what? Earth. And the second one is thermos. This one, like geothermal. Thermos means heat. So in simple meaning, geothermal energy is thermal energy generated and stored in the earth. So it's the energy generated and at the same time stored in the earth. We call it geothermal energy. So thermal energy is, we know this thing. Thermal energy is the energy that determines the temperature of a matter. Okay. So if it is a temperature generated and stored in the earth, we call it geothermal energy. Like we've seen this before, but to make it more clear, we don't have the crust here. We don't have upper mantle, outer core, and inner core. So let's take around here 2000 kilometer. We don't have this. Around this 4000 kilometer, we don't have this temperature. But around this 6000 kilometer in the inner core, we have 5000 degrees, which is really hot. So we can use this energy source, a good opportunity as an alternative source of energy. So the main question is, where does it come from? We have seen the meaning of the geothermal energy, and here we have the question, where does it come from? So initially, the energy transformed starts from way down at the Earth's core, here, which is like 4000 miles down. At the core, temperature may reach, as you can see, at the core, temperature may reach 9000 degrees Fahrenheit. Heat conducts from the core. We have core, right? So heat conducts from the core to surrounding rock. I think we don't have three ways of heat conduction. The first one is conduction, and the third one is radiation, right? So it's gonna be between solid, which is conduction. So heat conducts the core to surrounding rock, right? So extremely high temperature and pressure cause some rock to melt. So we don't have, at this point, we don't have extreme high temperature and pressure, which can cause the rock to melt, which is commonly known as magma. Bear this in your mind. We call this thing magma, which is like the high temperature and pressure causing the rock to melt and commonly known as magma. So magma converts upward since it's lighter, so it comes to upward than the solid rock. This magma then hits rock and water in the crust. So we don't have the crust, we say the upper part. So this magma hits up the rock and the water in the crust, sometimes up to 700 degrees Fahrenheit. So this magma near the Earth's surface is what is used and transformed in power plants. So this is like that we are transforming into energy source on the currently existing systems such as power plants.